12.3 deals with sector, area, and arc length. So first thing we're going to look at is our sector area. So the area of a sector is a fraction of the circle containing the sector. To find the area of the sector whose central angle measures m degrees, multiply the area of the circle by m divided by 360. So if we have a circle here, our sector is just like this, a little piece of the pie, as you could say. So our area of the sector would just be this part here. So the sector of a circle is a region bounded by two radii of the circle and their intercepted arc. So here we have sector ACB, so it's named by the angle, but it's a sector, so it's talking about all of this in here. And our formula is the area is equal to pi r squared, so this is just the area of the circle, times the measure of the arc degrees divided by 360. So this formula is very important. So this brings us to our first example where we need to find the area of the sector. So give each answers in terms of pi and rounded to the nearest hundredth. So we're going to look for sector HGJ. So this shaded gray part here. So our formula is the area of the circle, so pi r squared, times the measure of our arc degrees divided by 360. So we have pi, our radius here would be 12, so pi times 12 squared, and our measure of our arc is 131 degrees. So we have 144 pi times 131 divided by 360.
Miss Carver, you know that 131 is the arc degree because it's like the whole thing, or like?
So we said that in, I think it was 12.1, that the measure of our central angle is the same thing as the measure of our arc.
Oh, okay.
Okay, so now we can put this into our calculator. It wants it in terms of pi. So we're going to leave it in terms of pi, and then it also wants it rounded to the nearest hundredth. So we're going to do 144 times 131 divided by 360, which gives us 52.4 pi. And then we can multiply 52.4 times pi, which would give us 164.5. Round to the nearest hundredth, which would be 2 decimal places, so 5, 4. So these would be our two answers for this one, in terms of pi and rounded to the nearest hundredth. Any questions here? All right, let's go to our next example. So we have one more just like this. So we need to find the area of the sector. So again, we need that formula, which is the area of the circle, so pi r squared times the measure of the arc degrees over 360. So our radius here is 5, so we have pi times 5 squared times our measure of our arc is 25 degrees. So 25 divided by 360. So now we do 5 squared, so pi times 25 times 25 over 360. So we can multiply the 25 times 25 and then divide that by 360. Which gives us 1.74 pi, and then we can multiply this by pi. Which gives us 5.46. So in terms of pi, this would be our answer. And then rounded to the nearest hundredth, this would be our answer. Any questions here? Right. Next we have our segment of a circle. So the segment of a circle is a region bounded by an arc and its chord. So here, to find the area of a segment, so this is just our segment, this little green shaded part. We need to find the area of the sector, which is our piece of the pie, and then we subtract the area of the triangle, which would be this part. So to find the area of the segment, we need to find the area of segment LNM to the nearest hundredth. So we're looking for this shaded part here. So the first thing that we need to do is find out what our area of the sector is, which is this whole thing. So our area of the sector is going to be the area of the circle, which is pi r squared times the measure of the arc degrees divided by 360. So our radius is 9.
That's the area of what? The circle?
This is the area of the sector. So our radius is 9. So we have pi times 9 squared. Our measure of the arc is 120 divided by 360. And we can just put all of this into our calculator. So our area of the sector is going to be 9 squared, which is 81, times 3.14 times 120 divided by 360. So we get 84.78. So I just put all of this into the calculator. Did anyone get anything different?
I got 27, but I'll do my math again. Yeah, I got 27. Yeah, I still got 27.
Did you multiply it by 3.14?
Okay, now I did, yeah.
All right. Yeah, so it would be 27 pi, but we want our answer in the whole number. So 84.78. So that's our area of the sector, which is the shaded pink part. So now we need to find our area of the triangle, which I'm going to make it this green part here. So I'm just going to redraw our triangle down here, just so we can see it a little bit better. And we know that the legs of the triangle are 9 because those are a radius of the circle. And if this arc is 120, that means the central angle is also 120 degrees. So in order to find the area of this triangle, we need our base and our height. So what we can do to find that is we can cut this into 2 triangles by just drawing a straight line down the middle that's perpendicular to the base. If we cut this angle up top in half, we just made 2 60-degree angles. So we cut 120 in half, so we got a 60-degree angle. Now that we have a 60-degree angle, a 90-degree angle, that would make our third angle 30 degrees. So here we have a 30, 60, 90 triangle. In our 30, 60, 90 triangle, we know that opposite of the 30 is our x is half of our hypotenuse. So I'm just going to draw just a basic 30, 60, 90. Opposite of the 30 is x. Opposite of the 60 is x square root 3, and our hypotenuse is 2x. So if 2x is 9, that would make our x 4.5. And then that would make opposite of the 60 4.5 times square root 3.
Wait, how did you get 4.5?
I cut 9 in half. So,
Why?
because our hypotenuse, looking at our special right triangle here, if our hypotenuse is 9, to find what x is, I just divide both sides by 2.
Oh, okay.
So that gives me 4.5 for the side across from 30. Okay, now I'm going to put this into the calculator to find out what it is. So we have 4.5 times square root 3. Which gives us 7.79. But we have to multiply it by 2 to find what this whole base is. So our whole base here is going to be 15.59. I'm just going to round it. Okay, now we need to find the area of this triangle, which we can do that because we have our base and our height. So the area of a triangle is 1/2 base times height. So our base is 15.59 and our height is 4.5. So we get an area of this triangle as 35.07. Okay, now that we found our 2 areas, to find what our arc is here, to find the area of this segment, you can't really see it, but I made it orange. This segment, we need to do our area of the sector, which is 84.78, and subtract our area of the triangle, which is 35.07. So if we do 84.78 minus 35.07, we get 49.71. So this is our area of the segment. Any questions here? It's a lot of work, but all stuff that you guys know how to do. Okay, next example. So we're going to do the same thing. Find the area of segment RST to the nearest hundredth. So first thing we need to do is find our area of the sector, which is this whole part, and our area of the sector is pi r squared times the measure of the arc degrees over 360. So we have pi, our radius is 4, and our measure of the arc, it has that little box, so that means it's 90 degrees. So 90 over 360. And now I'm just going to put all this into the calculator and find out what our area of the sector is. So I got 12.56. Yeah. So that's our area of the sector. Now we need to find our area of the triangle. So I'm going to make this part blue. So I'm just going to draw it this way, which our two radius are the legs, our two radii are the legs, and this is a 90-degree angle. So here, we don't even need to use our 45, 45, 90 triangle because we have the base and the height already. And we know that the area of a triangle is 1/2 base times height. So our area is going to be 1/2 4 times 4. So our area of this triangle is 8. And
How do
now,
you know that the height is also 4, even though it's just the base?
okay, good question. Because our radius is this part of the triangle, and we also have a radius here, and all of our radiuses all of our radii of the same triangle are equal. So that would make this 4 also. Great question. Okay, now to find our area of the segment, so this green part, we just do our area of the sector, which is 12.56, and subtract our area of the triangle, which is 8. So that's going to give us an area of 4.56, and then our unit is meters, so meters squared. Any questions here? All right. Next, we have our arc length. So in the same way that the area of the sector is a fraction of the area of the circle, the length of an arc is a fraction of the circumference of the circle. So our arc length is the distance along the arc measured in linear units. So we can give our arc length a degree, which is the same as our central angle. So that's what we were doing, but now we're going to find the actual measurement of the arc in units. So in order to do that, we multiply our circumference of the circle times our measure of the arc in degrees divided by 360. So we're pretty much doing the same thing as we were before to find our area of the sector, but now we're using the circumference formula because the arc is just a portion of the circumference of our circle. So, our first example of arc length. We need to find each arc length, give answers in terms of pi, and rounded to the nearest hundredth. So we're looking for arc FG. So we're looking for this arc length here. So our formula, we said, was 2 pi r times the measure of the arc in degrees divided by 360. So our radius of this circle is 8, so we have 2 pi times 8 times our measure of the arc is 134 divided by 360. So now I'm going to multiply 2 times 8 times 134 divided by 360, and that gives me 5.955 repeating, which I guess I can just round it to 5.96 pi. So this is our answer in terms of pi. Now I'm just going to multiply this times 3.14, and that gives me 18.7. So here's our answer in terms of pi, and then here's our answer rounded to the nearest hundredth.
On a quiz or test or something, will we have to answer both or no? Like in both ways?
It'll be specific. So I probably won't ask you how to do both ways in one question. It'll be specific on which way. But the homework, the first two that are like this, ask you to give both answers. So in terms of pi and rounded to the nearest hundredth. Okay, last example. So again, we're going to find the arc length of NP. So we're looking for this arc here. Our formula for arc length is 2 pi r times the measure of the arc in degrees over 360. So here we see our radius of the circle is 6, so we're going to plug that in for r. And then our measure of the arc. Here the only measure of degrees that we have is this angle, which is 75. We know that angle PQN, this one here, also has to be 75 because these two are vertical angles. And we know that vertical angles are congruent. So this angle is also 75, which makes our arc length also 75 because it's equal to the central angle. So we have 75 over 360. And now I'm just going to plug everything into the calculator. So we have 2 times 6 times 75 divided by 360 gives me 2.5 pi. And now I can multiply 2.5 times pi, which gives me 7.85. So this is our answer in terms of pi. And this is our answer rounded to the nearest hundredth. All right, so that's 12.3. Any questions?